Hi everyone, I'm Prakriti from Sri Venkateshwara College of Engineering, Bangalore. Today I'm here to talk to you about the topic corrosion and its causes. Before getting into the topic, we all agree to the fact that none can destroy iron but its own rust can. Yes, here the word rust is referred as corrosion. Now let us know what is corrosion. Corrosion is the deterioration of materials by chemical interaction with their environment. The term corrosion is sometimes also applied to the degradation of plastics, concrete, and wood, but generally refers to metals. Now, in this topic, we are going to learn about introduction to corrosion, causes of corrosion, corrosion reactions, types of corrosion, how to prevent corrosion, and finally the conclusion. Now let's jump into the topic introduction. Destruction of metal by a chemical or electrochemical reaction with its environment. Physical or mechanical wearing away of metal is not called corrosion, but it is called erosion. If corrosion and erosion takes place together, the destruction of the metal takes place very much faster. Corrosion is an unintentional attack on the material by reaction with the surrounding medium. The corrosion problem should be very seriously considered in all those cases where the structure or the equipment is meant to last many years, say 20 years. Here are some reactions which are related to corrosion. And this is rusting of iron. And this is formation of green rust. Now let us know causes of corrosion. The chemical combined state of metal is known as ore. The ore has low energy in its thermodynamical state. The extracted metal has high energy, thermodynamically unstable. Metal converts itself into stable state by reacting with the environment and undergoes corrosion. The corroded metal is thermodynamically stable. And here formation of rust. And the disadvantages of corrosion. The valuable metallic properties like conductivity, malleability, ductility, etc. are lost due to corrosion. Lifespan of metallic parts of the machineries is reduced. The process of corrosion is very harmful and it is responsible for the enormous wastage of metal in the form of its compound. The failure of the machinery takes place due to loss of useful properties of metals. The approximate estimate of loss of metal due to corrosion is $2 to $2.5 billion per annum all over the world. Here, the types of corrosion. Different types of electrochemical corrosions are galvanic corrosion, pitting corrosion, intergranular corrosion, waterline corrosion. Galvanic corrosion. This corrosion occurs when different metals are in contact and in exposed to corrosive atmosphere. The metal which has higher electrode potential value will from anode and undergoes corrosion. Example, zinc and Cu, galvanic cell. Zinc behaves as anode and corrosion occurs. Copper behaves as cathode and it is protected. Pitting corrosion. When corrosion starts on a metal surface, at certain spots, they become less open to oxygen, with the result that corrosion proceeds faster at those very spots, making deeper and deeper cavities. Pitting corrosion can be explained on the basis of differential aeration. The pit created becomes deeper, its bottom becomes less open to oxygen, which makes it more anodic. The part which has higher oxygen concentration is cathodic. And waterline corrosion. The concentration of oxygen dissolved in water is greater at the surface than deeper down. This causes formation of concentration cell. Anode is the lower portion, cathode is the water level. Due to poor conductivity of the water ions, just below the water level are available for the reaction. The metal corrodes just below the water level. And here are the visual representations. And after knowing all the types of corrosion, causes of corrosion, Now let's discuss how to prevent corrosion. Protective coatings. Applying a protective coating on the metal surface forms a barrier that separates the metal from the corrosive environment. Common coating materials include paints, enamels, polymer coatings, and cathodic protection. This method involves making the metal to be protected, act as a cathodic by supplying it with a direct current or by connecting it to a sacrificial anode. The sacrificial anode corrodes instead of the metal to be protected. Inhibitors. Corrosion inhibitors are the chemicals that are added to the corrosive environment to reduce corrosion rate. They work by absorbing onto the metal surface, forming a protective layer that inhibits. Corrosion alloying. By adding small amount of alloying metals to a metal, its corrosion resistance can be significantly improved. For example, stainless steel contains chromium, which forms a passive oxide layer that protects the underlying metal. Environmental modification. Modifying the environmental surrounding, the metal can help to control corrosion. This includes controlling humidity, temperature, pH levels, or removing corrosive gases or contaminants. And the finally conclusion. Corrosion control is essential to prevent the deterioration of metals and alloys. Various techniques such as protective coatings, cathodic protection, inhibitors, alloying, environmental modification, and design considerations are employed to control corrosion. The selection of appropriate method depends on the factors such as type of metal, the corrosive environment, and the desired level of protection. By implementing effects of corrosion control measures, the lifespan and performance of metals can be significantly enhanced. And finally, let me tell you the interesting fact that corrosion also have an advantage. Amazing, right? Advantage of corrosion is corrosion prevents corrosion. Some metals like zinc are used to sacrificial anodes to prevent corrosion to other metals. Thank you.